Awesome. Can you see my screen now?
Yes.
Okay, awesome. So thanks, Mike and Phil, for having me. I am super excited to be here and kind of share with you some ideas on how you can use Pester to test your infrastructure. And this is kind of a new format of a presentation that I'm going to try to do here. So bear with me. This is my first time doing it, but this is my first time using this tool and kind of this kind of format. So, but by all means, if you do see something super interesting, you go ahead and put it in the chat window, and I may or may not see it, but feel free to stop me if there's a burning question you have to ask. I am going to go over a couple different tools, not super deep into each one, but give a nice overview of them. So there will certainly be deeper or more time for deeper questions at the end as well. So with that, let's get started. So infrastructure testing with Pester. Before I kind of go into that, I want to spend a few minutes kind of talking about what is software testing in general. Not infrastructure, but just traditional software testing that you're hopefully already doing with Pester for PowerShell. So first off, it is in general, it's an investigation conducted to determine the quality of software. You want to see if this software is up to snuff and is doing what you intend. It is meant to be objective. Oh, looks like I got some echo.
Oh, good.
There you go. It's meant to be objective and independent. It's not a person looking at your software and saying, I don't like this, I don't like this. It is a computer doing this, and it's an independent view of the quality of the software. It verifies that the software is fit for use, meaning that it does what it is intended to do. So software testing verifies one or more of the following attributes. The requirements that guided its design and development. So if you have a piece of software, you generally are going to have some requirements given to that developer about what that software is intended to implement. The tests will validate that indeed happens. It will also verify that the software responds correctly to all kinds of inputs and outputs. Meaning, if I give it this type of, let's say if it's a website, I give it this type, or a REST API, and I give it this type of JSON input, the software is going to act on that appropriately and give me back an expected response. Or if I give it the wrong type of input, that is going to deal with that condition in an expected way. That it's going to do all these tasks in an acceptable amount of time, and that could be anywhere from this service should respond back within 1 millisecond, or this process should complete within 10 minutes or 10 hours. Whatever that task that software is to do, we need to make sure that it's doing it in the appropriate time. That is sufficiently usable, meaning it's fit for purpose. Again, going back to requirements and whatever the customer is expecting of that software, that the tests are what validate that that is indeed happening. And it can be run in its intended environments, meaning I can test this software, for instance, on-prem, and I also am deploying it into the cloud. I'm running tests to make sure that that succeeds in both those cases. And ultimately that it achieves the result its stakeholders desire. So what about infrastructure testing? Infrastructure testing is a little bit different, that we're validating the operation of a system or an application or some type of service that we're offering to a customer. Some examples of what we would probably be testing in the case of a website would be, does this website respond with an HTTP 200 response given a certain input? It could also be, is the Windows service XYZ running, or is this service stopped? We have a requirement of the system to be in a certain state, and we're going to run some infrastructure tests to validate that that state is what we expect. Another example would be, is a certificate expired on a website, or is it about to expire? is the current state of the system what I expect? Meaning if I have an application with a certain configuration setting here and a different configuration setting here, I will run tests to verify that those settings are indeed what they're supposed to be and that someone hasn't gone back around the system to make a change. Another use case would be infrastructure properties. In this case, I mean external things like Active Directory membership for certain things, or Azure settings on storage accounts. You know, I could validate that all of my storage accounts are enabled for SSL and don't allow anonymous access, or some type of property or policy. I would like to test that. And ultimately, again, is the system operating to the customer's expectations? And that could be application owners, that could be external customers, internal customers, your own coworkers, etc. So why do we do this? Ultimately, we want to validate that the current state of the system is matching what our expected state is. And often in infrastructure, things change and things kind of evolve over time, and systems get upgraded or versions get changed, and our monitoring doesn't always keep pace. And what we intend to do with infrastructure testing is to make sure that the current state, as that evolves, is matching what we expect, or we change our expectations as the service evolves. We also want to notify us in some fashion when those cases differ. And this could be emails, this could be service desk tickets, this could be some other type of automation that runs to bring that system back into the expected state. But ultimately, we want some type of action to happen when our states differ. Another use case would be sanity checks before and after changes. This could be I'm running or I'm about to run some type of automation. For instance, let's say some automated patching of a system. Before I do that, I want to validate that that system is in the state in a sane state before I do that. Run the automation and then test the system again to make sure that I haven't introduced any kind of unwanted changes or any adverse side effects. To provide guardrails for automation. Again, just like I kind of said, I'm going to unleash some automation on a system. I want to run infrastructure tests to make sure that that is safe to do so. And that could be anything from making sure the system is up before I run this script against her, or making sure that the system is down before I run the system. I need to maybe run a script to drain servers off a load balancer. I want to run a test to make sure that that is indeed happening, run whatever my maintenance task is, bring it back up, and then run another test to make sure that the system is back in operational. So let's look at some examples of that. Blue-green deployments. Kind of like what I said earlier, this is I'm going to stand up and if anyone doesn't know what a blue-green deployment is, it's basically I have a current system, let's call it A, running in production, and I want to introduce a new change or upgrade a component of it. A blue-green deployment would be I'm going to stand up an entirely separate instance of that system and cut over to it in some way, perhaps with DNS or a load balancer or something like that. But before I do that, I want to make sure that the blue service is in a good state, and the newly deployed instance, the green service, is in a good state. Cut over to it and run that test again to make sure that the now in production green state is servicing requests like it should, or is operating how I expect. Validating server settings. This could be similar to some tasks you would do with configuration management, but this would be, say, I have some configuration files on a system and that govern how some application works. I would want to run some tests to make sure that those settings are what we expect and that someone hasn't gone back in behind the scenes and made modifications to something. I'm sure people listening here can probably think of many different use cases where I want to validate some type of server setting before I make a change. and verifying state before proceeding. This is a good use case where just like I've said before, I'm going to run some automation on a system. I need to verify that that state of the system is in a good state before I do that. And I'll give you an example of what I did a couple of years ago that was similar to this. Is that we did a kind of a data center migration to a new data center a couple miles down the road in where I work, and we were going to do this live. I wanted to migrate 800 or so VMs from one data center, basically vMotion them into the other data center. And I wasn't really exactly sure what the current state of all those VMs were before we moved them. So before we unleashed and executed the automation to migrate those VMs, we would basically run some Pester tests to verify that that system is healthy, meaning it's responding. We were doing it in basic state. We were basically saying, can we ping the system? Can we connect to it with RDP, or can we PS remote into it to make sure that we can do some type of remote management? Can we, if we knew about what was running on the system, can we run a test to make sure that the application itself is responding? And if any of those failed, we would not migrate the system. We would kind of flag it and have someone do some extra validation on that system, and we would skip over it as we're doing this automated migration from one data center into the other. So why do we test again? Ultimately, it's so we can go fast, and this is driven largely by automation. Automation allows us to go very fast, but without an appropriate testing discipline, things can go bad very quickly. Again, so that testing ensures that what we're going to do is we're going to execute it in a safe manner, and that we have things in a sane state before we do something, or we've done something and now we want to make sure that we're still in a sane state afterwards. And ultimately, infrastructure testing allows us to bail or to abort our automation when we've deemed something to be unsafe to proceed. And if anyone has any questions so far, you can feel free to stop me if you'd like.
No, nothing yet.
Okay. So to put it another way, and I tweeted this out a while ago, but I thought this was kind of humorous, is that CI/CD pipelines, or automation in general, allow us to go 200 miles an hour. And these infrastructure tests are your seatbelts, airbags, anti-lock brakes, traction control, collision avoidance, and autonomous driving systems, so you can go 200 miles an hour without killing yourself or others. And that's really what these tests are. We're more and more introducing a lot more automation into how we operate things, which means it's generally lights out, or we have computers doing our work for us. We need to have tests in place to make sure that our automation is doing what we expect, and we do it in a safe manner. We can't rely on our eyeballs or our eyes and ears to make sure that things are correct. And so, can we do this with PowerShell? Well, of course we can, and that's why I'm here. So let's look at a couple Pester tools, or related testing tools in PowerShell. The first one obviously would be Pester. I'm not going to go super deep into Pester. Hopefully most people here have a pretty good understanding of its how Pester works at least at a high level. I will say that Pester is kind of the core component of what else I'm going to show tonight. But Pester is a core piece of all of this. I'm also going to talk a little bit about the operation validation framework. And this is a module originally created by Microsoft, and I'm at least a couple of years, maybe about a year and a half or 2 years ago, I kind of took over as maintainer of it. And what the operation validation framework is a tool to bundle and execute and kind of discover Pester tests. And I'll go over that in a little bit. The Assert module, and if people don't know what this is a PowerShell module that kind of provides some useful custom assertions functions that you can run in Pester if you're doing some type of more advanced tests. And it's not a requirement, but it is a good It's a good tool to at least know about if you're finding your Pester tests are becoming more and more complicated to test something or to test some type of use case. You can potentially look at the Assert module to see if that would help simplify some of your tests. PS Health Z. This is a module that I've released a while back that I'll go over, and what this essentially is a way to execute tests that are packaged in the operation validation framework remotely via a REST interface. And Watchman. Watchman is another tool I released a while ago that kind of also plays on this idea of using Pester and the operation validation framework, and allows you to not only run tests and define what tests are executed or from what modules, but also what to do when those tests pass or fail. So I can run some custom, what I call notifiers, basically to run, to send an email to, or to write to a log file or something like that, but execute some type of action based on passing or failing tests. And I would love to know about others out there. I know a handful more, which I don't have time to get into tonight, but I would love to know of other types of testing frameworks or tools that kind of play into the same space, that kind of hover around Pester and use Pester in new and interesting ways. I'd love to hear about those. Okay, so let's dive a little bit into Pester. It is the ubiquitous test and mock framework for PowerShell. We typically will use Pester to validate that our PowerShell scripts and modules and functions do what we expect them to do. So we'll run a Pester test to validate some input, or validate some output, or validate that a function executes something on a remote system in the correct way. Some of the common functions of Pester would be that it has describe, context, it, should, and mock, etc., and these different functions that you can use to group and define your tests and mock external dependencies. Here is a very simple function that we'll say it's called get answer to universe, and all this function does is return the number 42, because we all know that that is the answer to the universe. How would we test that? Typically with Pester is this example here. We'll write a Pester script. Typically it's whatever the function name is, .test.ps1. We'll load in our script via .sourcing, and we'll use the describe and context blocks from Pester to kind of order our tests. And in this case, I'm only going to show you one, but because this function really only does one thing. What we're going to do is describe an it, and this is what our test name is, and we're going to say the test is the answer. Oh, got some feedback. That the answer is 42. Inside the it block, we'll execute that function, capture the output, and we'll pass that into an assertion function called should, and validate that output is indeed 42. And if that was not the case, the should would throw an exception. Pester would see that and produce a failing test. And the type of output you would see with Pester would be something similar to this, where we're going to execute our test. You can see it executing, showing our describe block and our context, and running our it statement. The answer is 42, and that is indeed true, so the test pass. That's Pester at a very high level. And I'm sure you guys have or plan to have other talks that kind of dive deep into Pester, and those are awesome to kind of learn about. Pester is more and more becoming kind of a core technology that people need to be familiar with to kind of operate in the Windows ecosystem. So the operation validation framework, like I said earlier, this is a framework originally released by Microsoft. And what the idea of this is, it packages up Pester tests into a module in a certain folder structure. And the reasoning behind that is because now that they're in a PowerShell module, you instantly have versioning capability via PowerShell, via module versions. you can have you can distribute that module via the PowerShell gallery or your own internal NuGet-based repositories. And it's a familiar kind of format to package things. So if you've been operating in PowerShell for any length of time, you're probably familiar with how to create modules. Creating bundling these Pester tests into a module is really no different. This framework is fairly simple in concept in that it only has two publicly facing functions, get operation validation and invoke operation validation. So get operation validation, what this function does is it enumerates all the PowerShell modules inside your PowerShell module path on your system, looks for all those modules and does an inspection of them and looks for Pester tests that are in a certain folder structure. And this is what that folder structure looks like here, where in this case we have a top level folder. This is our actual module name, myapp.ovf, and we have our typical manifest file and PowerShell module file. But what the OVF framework expects is this folder called diagnostics. And inside that diagnostics folder, you're going to have two subfolders, comprehensive and simple. And inside those is where you would put your Pester tests that are designed to test the operation of some system. The difference between comprehensive and simple is that oftentimes when we're running tests to validate a system, some of those tests could be very quick to execute. Perhaps I'm doing a get on a API endpoint that should return very quickly, or I'm running a longer performance-based test where I want to run something for a few minutes or maybe an hour, and I want to capture all those results and kind of determine the health of a system based on some long-running task. But I may not want to run all of those tests all the time, and the comprehensive and simple is a way to separate those out into different types of test categories. You can see in this example I have a handful of Pester tests named performance for a comprehensive test, and a couple in the simple folder called app, memory, and services. And I'll show you a little bit about what these look like. So the app tests. This is a very simple one, and that this Pester script is basically going to test that, in this case, the PowerShell gallery website responds, and it responds with a status code of 200. And if people don't know this feature of Pester, is that you can pass in Pester, just like a normal PowerShell script, you can have a parameter block at the very top and you can pass in parameters to a script. What some people don't know is that Pester is also able to pass in values into that parameter block. So you can have a more generic Pester test, maybe with some default settings, but then you can tell Pester to override those settings with other values. So in this case, I have an app test that tests the PowerShell gallery, but I can also use Pester and insert a different URL or a different status code, and I don't have to change my test. I can just pass it different values. And the operation validation framework also allows that concept of overriding parameters if they're present. So, and this is a nice way to help make more generic type tests. Here's a little bit more detailed example. In this case, I'm going to use Pester to test that a handful of Windows services are started. And here I've used another feature of Pester with a tag. If you can see here, I've categorized certain tests as critical and others as important. And this is kind of an arbitrary grouping of services in this example, but you could probably see a use case where I would like to use tags to categorize certain tests. And Pester, you can also run tests based on tag. OVF framework also allows you to execute tests based on tag or everything but a certain tag. And in this case, I've categorized a couple services as critical and important, and I've gone ahead and looped through an array, and I'm going to run an if block to validate that that service is started. And if this is an example of what that execution would look like with OVF. You see at the top here, we're going to use the get operation validation function, pass in a module name called myapp.ovf, and we're going to get a collection back of test objects. We can also pass that collection of objects into invoke operation validation to actually execute them. Internally, what invoke operation validation does is actually takes all those objects and actually runs Pester, invokes Pester to run those files. It does a little bit of massaging of the Pester output and returns you back some objects. It does also allow you to see the native Pester output if that's something that you're interested in. You can also, with invoke operation validation or the get command, you can also pass in tag or module version to be more specific about what exactly the tests you're going to run are. And you can see in this example that I've run this all the tests inside this OVF module. Every one of them passed, but the bottom one here where I have WinRM stopped. And then you can take this output and bundle this in your existing automation to make some type of decision, like, do I want to patch this server or do something on this server knowing that one of my infrastructure tests have failed. So the assert module. It's a set of advanced assertions for Pester to simplify test authoring. And it has probably a couple dozen different functions. I've only listed a few of them here. But what assert does is you have some, once you may find yourself doing some rather exotic comparisons of objects or of collections of objects to make sure that your expected state is matching your current state. Here I've listed you can do an assert contain, which does some advanced string comparisons. You can do assert equivalent, which is a function that will do some more advanced equivalence operations of strings and objects. You can also assert that an object is of a certain type, etc. Here's an example of, and this is a simplified version of what I actually do in production, but here is an example of a infrastructure type test that would also use the assert module. But what this is doing is it's testing our current list of domain administrators in Active Directory versus some pre-approved list. And I've basically bundled those into two separate arrays, and I'm using Pester to validate that the current list of domain administrators is matching what is actually approved. In reality, this would be a much more involved test, but here's a good example of using the assert module to do a comparison of one array versus the other. And also another handy feature of assert is you can use these, you can specify these custom failure strings. And you can see that here with this fail message object, or this string. And what this looks like is this. So if I run Pester against that script, I can see I have 3 domain administrators approved. And in my example here of getting the actual list of domain administrators, I have 4. And what you would see with Pester and the assert module is something like this, where the assertion run would actually show you how many unauthorized domain administrators there were, and it would actually list them all in order. You can, of course, do that with native Pester and PowerShell, but the assert module is a nice way to do that in a very clean syntax. Okay. Excuse me. So PS Health Z. Like I said earlier, this is another module that I created that I was doing some reading on different ways of testing systems, and came up with was introduced to this pattern here a couple of years ago. And this is called the Health Endpoint Monitoring Pattern. And you'll see this is not a new pattern, but you'll see this used more and more, I think, especially as containers start evolving and getting more common. What this is a form of black box testing of a system. So you see this application box here that comprises our application and however many services or different components in that. My monitoring system on the left sits outside and doesn't really know anything about the internals of that application and doesn't need to. The health endpoint monitoring pattern is saying that I'm just going to provide a common interface out there on the edge, and the monitoring agent can query that for my internal status, and I can get back some type of known response. In this case, I'm going to do a GET request against a HTTP endpoint on my system and saying basically, are you healthy? What that will trigger is some type of internal health check system to get invoked to check the health of the stores, the database. Do I have appropriate amount of database allocated? Do I have enough free disk space? Are all of my services running? Maybe do some quick performance-based test to see if I am responding, or different components of my system, are they responding in an appropriate amount of time? And the health endpoint will return basically a JSON response saying, yes, I am healthy. Here's some attributes of the health check that I performed, and you, Mr. Monitoring Agent, can do with that what you will. And this is a nice pattern to implement when you have many separate types of systems out there that would be impractical to try to monitor with a single tool or single agent. You just rely on that application to excuse me. You just rely on the application to do its internal monitoring and give you back a response. So, excuse me. PS Health Z has a couple functions in it. Get Health Z Listener will basically return any currently running instances of this HTTP server. Excuse me. New Health Z token will produce you basically a token that you can use to secure this health endpoint. Internally, what HealthZ is doing is running your OVF modules that you have on the system. You may want to secure that endpoint so only certain people or certain systems can access that, and you can use that by basically providing a token to the listener, and only HTTP requests that give that token as a header will be able to execute that test.
So a question there, Brandon,
sure.
from in the chat is that could you use possibly integrate this with Azure Functions and use this, like throw it at Azure Functions or that kind of thing?
With the issue with Azure Functions is that they're intended to be short-lived. So typically an Azure function would execute for a fraction of a second, or I think that in the case of Azure Functions, I think the max is maybe 5 or 10 minutes that those functions can be alive. This type of pattern is probably not the best suited for those short-lived instances. This is really meant for long-lived servers or containers that are longer-lived, and you want to be able to test the internal health of that system without actually having to know what the internals of that system are, if that makes sense.
So it's like making it a bridge.
Right. It's kind of an abstraction of the system. My monitoring agent only needs to know if I want to determine the health of the server over here. I just hit this HTTP endpoint, and I'm going to get back a response, and I'll parse it and determine if that's healthy or not. But I don't need to know the internals of that, and maybe I can rely on the application team who owns that system to be in charge of that. And me as an application or a server administrator, I don't need to know the details of that.
So you could set this up as to be something for other people to consume at that point, in that fashion, in that use case.
Yes. Yeah, and this pattern or this concept, I certainly didn't come up with this, but this is more and more common in containers and you'll have this with the sidecar pattern in containers. Well, you have your application in one container. You'll bring up this sidecar container next to it that is maybe running a monitoring tool of some type. And external systems, if they want to validate the health of the container, are actually going to query a health endpoint on that sidecar. Sorry, voice is giving out on me. Okay. Any other questions on that?
So I was asking some questions of the group while you were chatting. I don't know if you had a chance to see any of them. I was basically kind of get a feel of who is using Pester today, and I think you probably would be not shocked to hear that it's not widespread usage. People are just starting to get started with Pester. So my question would be, because this is me, I'm interested in Pester, but I haven't done anything with it. When we're talking about infrastructure as code with Pester testing, is this something you think people should really get the foundations of Pester down, and then this is something you build on later on? Or is this an area you think people could start with? I mean, is Pester something you need to master before you start going into infrastructure testing?
You certainly, I wouldn't say you need to master Pester. You definitely need a working knowledge of it because everything is based on it. So I should be able to, and have a working knowledge of PowerShell in general. I would say your Pester tests, I mean, you need to know how describe works and context and what an it statement does. And that's basically what Pester is. And then what's inside that it statement is just PowerShell. I get something and I pipe that to should, and I say is x equal to y, and that's a Pester test. And if you apply that to different concepts, you can say, well, what is my test? Is this service running? Is this website responding? Is this list of domain administrators, is it correct? Is it, let's see, I have a use case, another one I have. If I have an InfoSec team who's coming down with some type of security requirements in the cloud or in some Azure resource, and they want to say, we're going to require that all Azure storage accounts, or that no Azure storage accounts allow anonymous access unless you're on some whitelist. Well, how would I test that? Personally, I would use some PowerShell to go enumerate all of the storage accounts in my Azure subscriptions and pipe that and run that through a Pester test to make sure that, yes, all of my storage accounts, or that none of my storage accounts are allowing anonymous access. And you can do that by just validating a property of the object that returns back from the Azure module. So I would say that you don't need to know the intricacies of mocking necessarily, but you do need to have a working knowledge of PowerShell and if you kind of browse through other people's blogs about how to do Pester, or you can buy the Pester book that would give you a nice working knowledge of how to do Pester. I would say spend a couple, days, familiarizing yourself with that, or maybe looking at other people's code out there on GitHub of how they've done Pester tests just for PowerShell modules. Most of those concepts can all be applied to how to do infrastructure tests. I mean, because really the only difference is that with an infrastructure test, I'm testing the state of some system, not the input or the output of a function necessarily. So, hope that makes sense.
Yeah, and then my question is kind of related in the fashion that it looks like somebody had the same question. So I still see it, you write PowerShell scripts and you run scripts and you modules and stuff like that. But then this is the idea that you then create modules that are effectively just a bunch of scripts that go and test. So you'd write a function that's nothing but a tester. And so is the workflows to simply just call like the Pester test and just let it go do its stuff? And that same thing is same thing with kind of like DSC. And how does that, like, hey, I want to just validate that all these servers have these services on, so then you would write a script that is effectively just running a test that just, I'm not sure how that inception works.
Well, I would say that the kind of the difference between this testing and with DSC is that DSC obviously is going to take an action to bring that state back into whatever desired state you want it in. So if a service is supposed to be up and the service is stopped, DSC should be starting that service again. It won't necessarily notify you that it did that or that something drifted. You'd have to come up with some other tooling out there to notify you that DSC or any other configuration management system is actually making changes to your system. This is a infrastructure testing is not necessarily intended to actually make changes to your system. It's really just to notify you of what the state is and if that state matches what it's supposed to be. So you would say, I'm going to run some automation to patch a server. I'm going to invoke the OVF module for that application to test, basically run some type of smoke test for that application to say, okay, it's running in some base state. It's probably safe to proceed with patching it, or maybe I did patch it and now I'm going to run the OVF module suite of tests again that are customized for that application, run its smoke test after the patching to verify that, indeed after patching, the system is still working.
Okay, yeah, so that's kind of where I was so it's almost like an action step in your workflow is to, okay, instantiate the Pester tests or the OVF tests as a group and say, okay, do this, then you can do your work and then do it again to make sure effectively you didn't break anything.
That's right, and someone in the chat room is mentioning like SCOM, and that's exactly how I kind of like to describe OVF, but better, or at least simpler than SCOM. I've been running SCOM, or have been running SCOM in some form since it was called MOM 2000, so it's been a while.
MOM.
But that's exactly what I kind of liken OVF modules to SCOM management packs. And you would have a management pack for Exchange, and one for AD, and one for SQL Server, and one for application XYZ, for rinse and repeat for every single application. They could potentially have their own OVF module specific to that application, and you could also have OVF modules that are testing generic SQL settings, like the SQL services are up or Active Directory services are running. You could have these more generic technology or focused tests, and you can also have application specific tests, and you can run one or both of those. How is this different than monitoring checks in SolarWinds? Honestly, it's not that different. Running Pester tests, either packaged in OVF or just standalone, are really not that different than some of the checks you're going to run with Storm or SolarWinds or anything like that. One of the advantages that I have with everything, either in Pester or just in PowerShell in general, is that it's all code that I can see that's visible to me and that I can put in source control right next to the application. And I think that's a really important concept to kind of embrace is the monitoring and tests for an application should be living right next to the source code or the configuration of that application. I've run into a lot of cases where, and this has been true I think for most companies, is you'll have many different application teams, and you'll have a core systems engineering or platform engineering sysadmin type team who kind of owns monitoring, and they're supposed to magically know how every single application in their environment works, and that's never the case.
Brandon, you kind of beat me to the punch there. So Jonathan in our group was on the call. We've talked about this in the past. So Jonathan has tools like SolarWinds in his environment, but as environments get bigger, Jonathan is not allowed to configure SolarWinds. So here's a way where you can write your own tests when you don't have to go through the corporate nonsense to try to get somebody to figure out a way to do the test that you need in the existing application. Or maybe SolarWinds can't do the test that you want to do. So when someone asks, how is this like SolarWinds? This isn't necessarily a replacement for the tools that are in place, but you can build tools that can do things that the existing tools can't, or you don't have the ability to do the configuration to make it more customized than maybe just a simple up-down notification.
That's right. And
hey, Mike, this is Jonathan. Brandon, I posted that initially. I appreciate your response. That's essentially how I'm using it right now. I just wanted to hear your perspective on it. We write scripts for AD health checks every morning, and we code them using Pester, right? So that was really one of the questions I had, because my teammates are like, why would we want to write something in Pester, like a Pester check, infrastructure check, when we already have SolarWinds? And my thought was, well, we code everything ourselves, and we know what to check. We don't have to work with a team for weeks over email for them to, then make it work in SolarWinds, blah, blah, blah. So that's really what I wanted to understand. So I think you answered it.
Yeah, right. And kind of to expand on that, one of the nice things about having these checks in a more generic framework like just plain PowerShell or Pester versus embedding a lot of custom logic inside tools like SCOM or SolarWinds is that I can switch monitoring platforms fairly easily when all of those systems are only, what they're essentially doing is just running a Pester script. So if I have SolarWinds running that Pester script and I choose to change to a different monitoring tool, that new monitoring tool can just as easily run that same Pester script. I don't have to retool or redesign how I'm doing monitoring from the ground up. I have most of my logic is already there and is portable. I've done the same thing where, in my case, I had some checks in SCOM, and I was evaluating Sensu, if people are familiar with that tool. And kind of similar to this health endpoint pattern, but not using HTTP, what I was basically doing is I had some OVF modules deployed on some servers, and I was using Chef to deploy them, but you could use Puppet or DSC or anything else to kind of deploy modules onto systems. What I was doing is that I would also have a PowerShell script called smoke test in a known location deployed onto the server, and Sensu and Chef would detect if that file was present, and if it was, they would instruct Sensu to run or to execute that file every 5 minutes or whatever. And that script would do whatever it needs to do. Sensu doesn't care what that script was actually doing. It only cares about the output that script returns. So Sensu has a certain output that it likes its scripts to return as a certain return codes and certain output format. But what that script does internally, it doesn't care. So I could have Sensu running a PowerShell script. The PowerShell script was running OVF to go execute, OVF module tests and kind of massage them and determine if they fail, and if they did, return a certain exit code to Sensu. But Sensu was oblivious to what was going on internally. It was just saying, I see a smoke test script, I'm going to run it every 5 minutes. So I could have a generic rule in Chef and Sensu to say, if you have a smoke test, I'm going to run it. What you application team decide to do, how to monitor your system, is up to you, as long as you conform to the requirements of Sensu and its output format. But what you do in that smoke test is up to you. And I enabled them to help own their monitoring and not rely on the central application team or central engineering team to know the ins and outs of every application, because that's not feasible. Hope that answered.
So if you're not
using questions
like SolarWinds or anything like that, so what do other people use as far as like an orchestrator or a scheduler at that point? So I can do some of the stuff, but am I just using Windows Event Scheduler to keep those on?
You could. It's agnostic to what you're using. So in my case, I was looking at Sensu, which has its own basic orchestrator and scheduling to run scripts, what it calls checks. basically, but what they're really doing is just running scripts on the system. Nagios, which essentially was kind of based off of, has the same concept. You could use SolarWinds. You could write a generic rule in SCOM to say, look for this script on the system and execute it if it's there, and parse the results. But these tools themselves they don't have an opinion on the orchestrator or the overarching monitoring platform. If that makes sense.
Hey, Phil, we at work I just integrated some Pester scripts into Jenkins, and Jenkins for us is just simply scheduling these scripts to launch every day at like 9 a.m. right, for an overall AD health check. So that's what we did, and I integrated it with our internal Git repo and all that good stuff. So that's worked pretty good for us.
Sure. Yeah, you could use Jenkins for that. What we've also done, wasn't necessarily to monitor the health of systems, but like I was showing you with that Active Directory, the domain administrator check, I was running that in GitLab with GitLab CI as basically a scheduled build. And I had our approved list of domain administrators in a certain Git repo, basically as a text file that only certain people could modify. And in this other repo, I was running this check to read that list and also compare it with what was actually in Active Directory, fail if they don't match. And that was just run as a scheduled CI build in GitLab every day. And I could also hand those results to auditors and say, here, produce a kind of a pretty report, or basically just a CSV file, and saying, here is our daily compliance audit check for domain administrators, and even give them the ability to run that build ad hoc.
Sounds cool.
So, and we've kind of started to extend that same concept to other different types of compliance checks. And they all get boiled down into some Pester script running either scheduled in GitLab or in VSTS, or you could do it in Jenkins or any other system that basically will kick off that script for you.
Yeah.
Okay. Let's any other
keep
questions before I move on? Nope. Okay. So PS Health Z, let's get back to that a little bit. Here's how you would go ahead and start PS Health Z. Because like I said, it only has 2 commands or 4 commands. You would start Health Z. You provide it a port optionally. You provide it a HTTP path. In this case, it would be health, so it would be like localhost port 8080/health. You could pass through, and that will return you back an object. What Health Z listener is doing is it's basically running a PowerShell HTTP server as a separate job, a separate PowerShell job. You could also use the get Health Z listener command to return any running jobs, and you can even run multiple. Since they're in PowerShell jobs, you can have multiple listeners running on different ports. There are other parameters with the start Health Z listener command, so you can pass in a token or provide a certificate thumbprint that you've already installed in the system if you want to enable SSL. With the caveat that only works on Windows. On a Mac, SSL support doesn't work right now. You can also choose to use anonymous authentication, or you can provide a token to do token-based authentication. So here is how you would actually use Health Z, or an example of it. So I have Health Z listening locally on port 8080, path health. I can basically just use invoke rest method to query that endpoint and give me back a JSON response. And by default, Health Z does not actually execute any OVF tests. It requires you to provide an extra query parameter specifying the test or the module, OVF module name of the test to execute. And here so it provides you that helpful message here. You need to provide, in this case, either test equals everything, or I want to execute every single module, OVF module in the system, or some subset of those. It will also list here what OVF modules that it found on the system. So if we actually look, whoops, so that was tests. So we can also look at the available tests, and you can see I have 4 here from all from the single module OVF Windows server. This name here maps to the describe block of Pester. So if I have a describe block called logical disks, that's what gets reflected here is the name of that test. And here's how you would actually execute an OVF test with PS Health Z. I would use invoke rest method, provide the URI, specify the name of the OVF module to run, and I'm going to get back some type of result. So let's look at that result a little bit. So in this case, this one did not pass. It will show you how long the test took to execute, and this took just over 1 second. The list of available or the tests that it executed, and then these 2 properties here are much bigger collections of the actual Pester test results. And I've also grouped just the failing ones into a separate property, really out of convenience. So if we look at that failed test collection, this is an example of what you'd see. So you'd see the test name, and this maps to the name of the it block of Pester. Give you the module that test came from, its result, its describing context, the ultimate file path to where that test was executed, and any kind of output from Pester for that test. So that's Health Z in a nutshell. I guess I'll stop here if anyone has any more questions about how that works. No? Okay. Or someone have a question?
Nope, I was going to say no.
Okay, cool. So Watchman. This is another module that I created when I was kind of knee-deep in testing infrastructure with Pester. I came up with this module called Watchman. And what this is another way to execute OVF and Pester results. And like I was mentioning earlier, Pester, by default anyway, does not take an action based on tests passing or failing. It just shows you that yes, they did or they did not. What Watchman is intended to do is actually take action based on those tests, passing or failing. And it plays on the concept of OVF. So what Watchman will do is it will inspect your system for installed OVF modules and run those tests. It really only has 2 commands: get Watchman test and invoke Watchman test. And like I said earlier, what Watchman is really intended to do is to take action based on those tests. So in Watchman, I call them notifiers. And what these are different actions you can take, like sending an email based on a failing test, or writing to the event log, writing to some text-based log file, executing a arbitrary PowerShell script that you define, or even sending a Slack message or sending to syslog. So here's what a Watchman file would look like. And this is a normal PowerShell file with a DSL that I came up with to kind of simplify how this is configured. Is you would specify, you run the function called Watchman test and provide it the name of an OVF module to execute, and optionally a version or the name of a PowerShell PowerShell repository on the system to go get the module from if it wasn't installed already. You would then run a notifies block and tell it n number of actions to take based on those tests. And you can provide it an additional qualifier of that's called when, which is run the log file notifier when the test passes, when it fails, or when either of those happen. So there may be cases where I want to run a extra PowerShell script or to write to a log file regardless of that test fails, but I only want to send a Slack message when the test fails, or something like that. And here's an example of what the required properties would be if you wanted to have this send a Slack message. So you would need a Slack, a web token, provide it the channel name to send it to, and a little bit of properties here to define what that message looks like. And at the bottom here is how you would go ahead and get those tests. So you would run get Watchman test, pass it the path to that file. It's going to return you an object with the collection of the tests to execute and their configuration for the actions. And then you can pass that to invoke Watchman test. And that will internally discover all those modules with OVF, with the Operation Validation Framework, and execute them with Pester. Here's an example of that log file notifier. As you can see, I ran the Watchman, the invoke Watchman test function, and I've set it as a notifier to write to this log file. And here's an example of what that log file would look like. And you would have one line basically per test executed, failing or succeed. And I've also set the Slack notifier. Here's an example of what that Slack message would look like. And in this case, I would also include the name of the system that test was executed on, the name of the module, the name of the test, any kind of describe or context blocks, the actual path to the file, and whether or not that test result passed or failed. So let's go, I kind of went over this during the course of the talk, but let's look over some example use cases that you can kind of use this infrastructure testing concept for. Like I said earlier, smoke tests. Here is an example where you can combine multiple tools together to produce some type of workflow. So I can say I have OVF tests deployed on a system via DSC, Puppet, Chef, what have you, or even manually. I have also configured PS Health Z to be running on that system via a service. So I have a HTTP server always running on that system. And I also have Poshbot deployed into the environment. And if people don't know what Poshbot is, it is a PowerShell-based bot framework that works with Slack and with Teams, which allows you to basically run PowerShell commands from within Slack or Teams. So with this example, I can also have Poshbot. I can have a custom Poshbot command that would query, do an invoke rest method on that health endpoint, parse the results, and give those back to Slack. So I can run an ad hoc test within Slack, or I can give this command and have anyone I deem necessary be able to execute this command in Slack to test the systems that they need to. I've also mentioned this before as a compliance audits. You can, and we do this, and we do this way more with just domain admins. We do this kind of compliance audit for a whole host of settings and security related settings. Is I can say I'm going to validate the domain admin list in production is exactly what I've defined it, or someone else maybe has defined who are the approved domain administrators. And I can run this test daily, hourly, every minute if I want to. Like someone was saying, either with Jenkins or with SolarWinds or with any other type of scheduling or orchestration tool, I can run these tests and alert me when any of them fail. And here's this is more of a POC I did. I haven't run this in production, but this is an example of combining a couple different technologies together to kind of give you a pretty dashboard, kind of reimagining how monitoring could look like. So this is a Grafana dashboard where I have an agent running on a system to gather performance-based metrics and store them in a time series database. And in this case, I was using InfluxDB. What I was also doing is running scheduled Watchman checks, I think via task scheduler, and running basically saying if a test fails, that is a 1, and if it passes, that is a 0, and then sending those as time series metrics into InfluxDB. And now that they're basically 1, 0 type metrics in a database, I can now graph them with Grafana, and I can show you test failures over time, or succeeds over time, and how that system give you kind of an overall health of the system over a time frame. And I can also provide what's called basically a Christmas tree, red-green type dashboard of what is the current value of these checks. Are they 1 or are they 0? If they're 0, it's a green box. If it's 1, it's a red box. And I can give you a nice, easy to glance at visual of the health of a system. So, just kind of wrapping up here. Let's kind of go over some good practices when it comes to infrastructure testing. Focus tests on what the user sees. This I've run into this many times, and I'm guilty of it myself. We as IT administrators and system admins tend to want to monitor hardcore system level metrics, and less so the overall health of an application. So the performance of the CPU or the amount of disk space on a system really is not all that important. It's interesting to know for forensic use cases or maybe for troubleshooting, but it doesn't. The fact that my CPU is 90% does not tell me if my application is slow or is operating completely normally. So if my memory is 90% CPU, maybe that's bad, but if it's a SQL server, that's completely normal, and that's exactly what it should be doing. So alerting on those types of metrics is not that valuable. It's much better to run tests to test what the actual user will see from that system. So is the application returning a web response in less than 1 second or something like that? But the fact that web server is 50% CPU or is 90% on memory does not mean that application is not healthy. That could be completely that's normal for that application. Don't alert me on that. Alert me when my service level metrics start to exceed what we've designated. Start small and iterate. You're not going to get this stuff 100% right out the gate, and this is meant to be continually improved upon over time. So I would say if you're going to look at starting to implement some of these tests, start small, start basic. You could say, does the server respond to a ping? And that could be a very bare bones up-down type test for the system. And then iterate on that as you learn, if you have time, and as you learn about how that application behaves, what are the good external type checks you can run on that system to kind of gauge its performance. And then once you've done that, also then go in and maybe inspect some internals of that system to check on health. But really kind of focus on the external things, like is the application up? Do I get a response? Focus on those types of tests first. Those tests should also be in version control. And ideally, right next to the application code or the configuration management code for that application, if you're doing that. I've found that it's much easier and much more likely that your tests will be accurate if they're right next to the application being deployed. This is kind of the similar concept to documentation. The further documentation is from the system, the more likely that it's going to be out of date. Use configuration management, if appropriate, to deploy those tests into your environment. Please don't RDP onto a server and manually drag and drop script files onto the system. Use things like DSC and Chef and Puppet to have more control over the configuration of your systems. So putting things in Git, deploying them to the systems with configuration management is a plus. Now that they're in Git or they're in source control and they're deployed with configuration management, now it makes it easier for your application owners to author tests. And this is like I was saying earlier, oftentimes the role of monitoring is put on the system level team, and those teams generally don't have the best context for how to monitor business applications. They may have a good context to monitor infrastructure, AD and SQL Server and things like that, but not line of business type applications. Typically, application owners, business analysts, or system analysts who live in that application day to day know exactly what to check for to see if that system is healthy. A system administrator 4 people removed from that process is never going to have that knowledge. So expecting that person to figure out how to monitor that system is really not the best scenario. So think of ways that you can make the task of testing easier and more consumable by an application owner to do. And if you can do that, it's much more likely that you're going to have high quality tests for that application. Automate tests into the environment. This could be either with configuration management or with just CI/CD type workflow. But if your tests are in source control, it's fairly straightforward to run some automation based on check-in into source control to deploy those tests out into the environment. And really, at the end of the day, what we're trying to do is make it easy to do the right thing. And what I mean by that is you want to make the task of setting up tests and monitoring checks for your systems as easy as possible, because that is the only way that they're actually going to be done. In general, people they follow the path of least resistance. So if the task to monitor a system is arduous and very complicated, and I need to spend a month learning how to use XYZ monitoring tool, it's much more unlikely that I'm going to do that as an external, like an application owner, versus if I'm provided a framework and I'm provided guardrails to say, put this file in this location, and our monitoring system will take care of it, and that's all you need to do. It's much easier for that to be successful if it's very easy for whoever is responsible for putting that monitoring in. If it's easy for them to do that, it's much more likely to actually get done. So with that, that is the end of the presentation. I'd like to thank everyone for attending and kind of listen to me drone on about testing. And if anyone has any kind of follow-up questions or wants to get deep into something, you can certainly let me know.
T. Hanks is awesome. Hey, I have a question for you.
Who doesn't like Tom Hanks? Really? Is there anyone alive who doesn't like Tom Hanks?
So my question for you is, I know where you work. Did you come to a place that had some sort of Pester and infrastructure testing in place, or did you set that up at the place? And the reason I ask that is, how much work did you have to do to bring the rest of the business around support if you wanted to do these types of tests?
Mm-hmm. So I will say that we're still on the path to getting all these to getting our stuff monitored in a more modern way. I put in Pester tests for things like compliance things maybe 3 years ago, and that's now the primary way that we kind of do compliance type tests. And more and more, we're even getting that extended to non-Windows systems. So we'll test. Basically, we'll get an export of some system. We'll run a Pester test to validate that expected state, and we'll provide that to the auditors. So that's becoming more and more the standard way that we do checks. And once we did that with compliance tests, we're doing that more and more with things in Azure. So we're, like I was saying earlier, we're doing validation of, so if we have a policy that says storage accounts must not allow anonymous access, that's a fairly easy Pester script to write to enumerate all the storage accounts and just check them. Are any of them allowing anonymous access? And if they are, fail and alert someone about that. Kind of rinse and repeat those for more and more systems. I will say that application level testing is going to be harder, and we're not there yet. It's easier to do with infrastructure, like system-related things like SQL Server, Active Directory, VMware, what have you. It's more difficult to do it with applications because each one is different, and you need to have application owners who are willing to kind of embrace that way of thinking, and that takes time. That in a lot of cases, those application owners may not know Git, may not have any kind of coding experience, so that takes time and quite a lot of human effort to kind of like one-on-one type time to sell that to someone and also then train them how to do it. And that's why the importance of, if you're going to do this, you need to make it as easily as possible for them to get onboarded onto that. Otherwise, it just won't happen.
Cool. So guys, with that, we are finishing up here. We went long tonight, which is completely fine because it was great content. But feel free to unmute your mic if you got questions, anything you want to say. If not, we will be posting this on a YouTube channel and GitHub repo. It will be available to you guys shortly. But if you have anything you want to ask, go for it. I saw a bunch of people duck out when you and I were just chatting, so I don't know how many people are still in the room.
No worries.
But, dude, that was awesome tonight.
Thank you. Hopefully everyone got something out of that, or at least got inspired on how they could apply some of these concepts. They don't necessarily need to use any of these tools. Hopefully they will use Pester, but they don't use anything else as long as, we use something to test.
Well, you bring up a good point. I have a coworker that I work with who's a little intimidated. You know what, Phil, if you want, you could pull the plug on the recording at this point. I have a coworker that I'm trying to mentor a little bit with PowerShell, and he's intimidated.